All right, good morning. Friday, I know it says Monday on here, but it's Friday the 18th. We're ACA. Today we're talking about column one-step equations with multiplication and division. Pause and play when you copy the warm-up and actually solve it out. Pause and play. All righty, so I'm not even gonna model. I'm just gonna focus on how we should do things mathematically. So x plus 20 is equal to 18. We're looking for what x could be. So when I solved these yesterday, this I'll put a slash where?
Like for the x
for the equal sign. That's the two sides of my like seesaw. Okay? To get x by itself, I see that it's adding 20. So to get rid of 20, I would need to subtract. Are you with me? What do I need to do? Subtract how much? So head up. Nope. Head up. Head up. Okay? Class, I need to subtract 20. Whatever I do to one side, I do to the other. Okay? So these 20s, what happens with those? The zero cancel out. There's zero pairs. I'm left with x. And then guys, be careful. 18 minus 20 is negative 2. Okay? Negative 2, because I'm taking a small number minus a bigger number. That's going to give me a negative. If I'm unsure, what should I do to check my answer? 20 what? Not quite. Yes. Plug it in. Okay? Plug this into that original equation. Negative 2 plus 20 gives me, class, 18. Is that a true statement? Yes. So x equals negative 2.
So like, would it be like that on the test and stuff?
Yeah.
Okay, that, well, like that problem right there would be the answer.
Yeah. Yeah. Okay. So on the next one, last thing. What do you think I'll need to do, Jackson, to get x by itself? I want to get rid of minus 20. Yeah, 0 pairs. And
That's each other out.
what would make the 0 pairs? A minus 20, a plus 20, plus 20. Okay? Whatever you'll hopefully start to recognize that it's just the opposite operation. What's the opposite of addition? And the opposite of division? They're going to go hand in hand. So I added 20 on this side, but to keep it balanced, whatever I do on one side, I do the same thing to the other. So just like y'all said, that makes 0 pairs very good. Over here, I'm left with x is equal to 38. If I'm unsure, plug it in. 38 minus 20, does that give me 18?
Yes.
Yes, ma'am.
For like the answer, would it be what x equals, or would it
This is what I'm looking for. Great question. I'm looking for the solution. I'm looking for the value of x. Miss Idle just likes to always check her answers because then I always get a first. Okay, here we go. On activity schedule.
Wait, did anybody get a
I can't remember.
when I'm talking around about things like
Okay, work over here. Okay, homework. Were there any problems y'all needed me to clarify on? Hey guys, we're in class and we're on me. Thank you so much. Okay, were there any questions from the homework that I could re-explain or clarify on? Okay, we're starting a new 6 weeks and some people already don't have their homework done, so it's going to be starting out rough. All right, let's hop into today. Yesterday we talked about addition and subtraction. Today we're going to talk about very good. And as Ms. Idle just mentioned in the warm-up, you're basically just always undoing what operation is happening. We're going to start with models because it gives us a little visual representation, and then we'll move into just the math. Okay, so on this first problem, they said solve 3x is equal to 12, and then they said that they modeled it. Okay, the x is an unknown value, and we're trying to figure out. So basically, how I'm translating what I see here is I'm trying to, I guess, split the different balls into the teacups, right? So, how many teacups do I see? 3, and if I want to split it evenly, I need to split it up into 3 groups. Okay, so how much is going to go into each one? 4. Do y'all agree? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If I didn't know how many were going to go in each one, you could also do this. You could say, okay, this is cup 1, 2, and 3. You can go 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then count up, I guess, all the ones. And there were how many? I would not go for that strategy, but I'm just showing you how you could. Okay? I would circle and group them together. Do y'all agree with that? Okay, so this goes to 1, 2, and 3. So X is going to be how much is in each cup, and there are 4 in each one. Okay? So let's keep going. Work with, no, we're not going to work with fire. We're going to work with Miss Idol. I am here for her. Unless you all want to try it? No. All right, y'all tell me. Okay, so the two sides, what's this over here? 4 what? I'm not going to do T-cups because that's not normal. I'm going to do 4X and use. Yeah. Okay, we're going to do the 4. We're going to do the algebra tiles, y'all. Sure. They're mozzarella cheese slices. Yeah, we're going to figure out how many raisins are going to go on each cheese slice. Okay, how many raisins do I need to draw over here? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to split them into 4 groups. So each group is going to have. Good. Exactly, and exactly, because Ms. Otto said we're going to split. What operation is splitting? Division. So I'm undoing the multiplication with division. Okay, so X is equal to 2. Do the next one, right? All right, on number 2, each X is going to get how many? 3. Very good, because 1, 3. Okay, but some of y'all have already moved on to number 3. What's different about number 3? It's negative X's. Okay, so we'll look at that. 1, 2, 3, 4, 5, 6, 7. But instead of X, these are negative X's. So I'm going to say negative X, negative X, negative X, negative X, negative X, negative X, and negative X. On the other side, that 14, is it positive or negative? Positive. 1, 2, 3, 4, 5, 6, 7, 8.
Signs are different.
Okay. Yes. So Lukemon's already at the math of it, but let's pump the brakes real quick. Each of those is going to get 2 of the circles, but I'm not done yet. Okay? The reason why, so I'm going to draw that each one is getting 2 of those circles, but that's saying that negative X is equal to 2. Are we ever solving for negative X? No, we're looking for positive X. We're looking for positive X. So there's a couple ways you can think of it. X and negative X are opposites, right? So I want the opposite of negative X, so I want the opposite of 2, which would be negative 2. That's one way to think about it. Okay? Another way, a more mathy way, again, negative X is equal to 2. This is going to seem weird, but let's start with what number could I put with that negative X? 1. I could put a negative 1X. Now, this is getting into the math, which is where we're going to get to in just a few minutes. But in these other problems, Lana said that we're basically just dividing to solve these problems, right? Okay? So to solve this, to get X by itself, I'm actually going to divide by negative 1. It's a little weird, but just go with me. Okay? Negative 1 divided by negative 1 would give me just 1. Okay? Give it itself. So I'd just be left with X, because those basically cancel each other out. 1. It's the same thing. Exactly. Over here, 2 divided by negative 1. Signs are different, so negative wins it. And 2 divided by 1 is? It's a little weird. Okay. Okay, so let me back it up. Just let me do one more. Okay, let me go back here. 3x is equal to 9. Again, we haven't done the mathy side of it, we've been modeling. But again, when I wanted to find the value of x, I'm going to split it in half, and I need to get x by itself. So I have to undo what happened. I see multiplication, and what operations undoes multiplication? Division. So I'm going to divide by 3, because that will get it by itself. Whatever I do to one side, I do to the other. Okay, so taking a step, 3 divided by 3, it gives me 1. It cancels out. It's nothing. So I'm going to draw that I cancel out, and I'm just left with that x. Over here, 9 divided by 3 gives me 3. Isn't that what we solved? Yes. Okay. Again, this right here, I'm doing the more mathy version. Okay. It's going to take some time, but we got it because we're going to keep practicing. Okay. Over here, we just did some negatives and the final negative 5p, but let's keep going. For right now, I do not want you to mark anything out, but we are going to skip this top bit. Okay, we're going to skip down and we're going to go right here where it says example 1. Again, you are not scratching it out because we will be coming back to it. Thank you so much. Okay, let's just keep going with these models. Again, we're going to get away from the teacups. We're going to do more of the algebra tiles and the mathy stuff. Okay, so it says solving with one equation. Let's work through a multiplication example together to visualize on the scale. So we have our seesaw right back, and of course this is still going to be my equal sign. And it says on the scale above, draw on the problem 2x is equal to 6. We're going to model 2x is equal to 6. So over on the left side, I'm going to draw 2 x's. On the other side, it is equal to 6. Yeah, we're doing this model thing from yesterday. Okay? So my goal is to get x by itself, but I have 2 x's. So when I'm solving this kind of problem, I want to get 1 x by itself. So I need to take off 1 x, but I need to take off the equivalent values. So let's first split them evenly. How many counters is going to go with each x? 3. Like these would go together, correct? And then these would go together. Are y'all good with that? Yeah. But I'm just solving for 1, so I'm sort of going to take off 1 because I only want to find what 1 is equal to. So 1 would be equal to, x would be equal to 3. Are we good with that? Yeah, sort of, kind of.
No.
Why not?
Because I don't understand how you put x equals 3 and
All right, let me try this one more time. Okay, again, I'm starting with 2x is equal to 6. Great. Okay, my goal when I'm solving an equation is to find the value of x, not 2x, x, just 1 by itself. So I'm going to take off 1 x value, and I need to take off the same amount over here, but I'm going to split them evenly. So therefore, I'm going to take off half of that. I took off half of the x's, I'm going to take off half of the numbers. Correct. So x is equal to, exactly. Okay? So, again, we're going to transition to the math version of it. Okay? This is what I saw some people skip yesterday. This is what I need you to do. So we're starting with that equation, 2x is equal to 6. 2x is equal to 6. Just like before, I split up the equal sign because that shows the 2 sides of my seesaw. And my goal is to get x by itself. To get x by itself, I undo what's happening. Right now, what's happening to x is getting multiplied. I undo it with division. So I'm going to divide. Miss Lytle will always, you will never write the division sign like over here, that kind of stuff. You will not do that anymore, really. Okay? The middle school and high school version of division really is that fraction mark. You're going to divide both sides by 2. Whatever I do on one side, I do to the other. Okay, so let's solve this. 2 divided by 2 is equal to 1. So I just cross that out. You can put a 1, but I just cross it out. I'm just left with x, so I'm going to bring it down. I'm starting new. 6 divided by 2 on this other side is equal to 3. So x is equal to 3. That's my solution. Okay? As always, sometimes you're like, I don't know if I just did that right. I literally have no clue. Plug it back in. Okay? Say 2 in parentheses times 3. Does that equal 6? Yes, it does. Okay? I'm going to do one more because this is like, because what do we see? We see a fraction. Okay, here we go. We got it. Same process. Because we've been doing the same thing, we have a solid foundation. Okay, over here. Okay, so I need to put 1/2 of x on one side and 6 on the other. I got 6. Let's do 1, 2, 3, 4, 5, 6. Okay, now for half of x, we've never modeled half of x. So what? Okay, it's not that crazy, but you're like, okay, so starting with x, but I don't have a full x, I only have half of it. That's half of x, do you all agree?
Yes.
Okay, but my goal isn't for half of x, my goal is to know the value of, no, my goal is to know the value of x. I only have half of an x, so to get, if I have half, I need how much more? Another half. I need another half. So I'm going to add another half of x, and so if I added half of x on this side, I have to add the same amount on the other side. We said that half of x is equal to 6. If I add another half of x, I'm going to add another 6. Very good. So a full x is equal to all of this. X is equal to 12. It's spicy.
Anytime you want to get to like operation.
Okay, pause. Remember, we're recording. Yes.
So anytime you want to multiply with 1/2 to get a number, you can do that.
Are you sure? Yeah. Okay. Let's look at the math. Okay, so 1/2 of x, I'm writing it bigger because I need to. 1/2 of x is equal to 6. This is going to be spicy. It's going to be weird. Okay, but it sort of goes off of what Luke Mon just said. As always, I need to split it, and I need to get x by itself. We're going to multiply both sides by 2. But we're going to do it in a specific way because with fractions, it's not always going to be 1/2. What we do is we multiply by the reciprocal. Okay, I'm going to multiply by 2 over 1. I'm going to multiply by 2 over 1. The reason why I have to do it by the reciprocal is this is a fraction, and so I have to have the other fraction. Okay? Let's take, I'm going to pause, okay? I'm not going to solve it up here. I'm going to solve it up on the board just so you can see it. 2 times 1 times 1 times 2. What does that give me? If I multiply 1/2, okay, it gives me 2 on the top, and that simplifies down to 1. So it's just canceling out yet again, and I'm left with x. Okay. Over here, to multiply that 6 times the fraction, I'm going to put it over 1. What do I get?
12. Over 1. 12 over 1 is 6.
It's 12 over 1, which is literally just 12.
Actually, 39.
Okay, and if you're unsure, let's solve it out. 1/2 of 12. Remember when we multiply, it's sort of like thinking of half of 12 is 6.
Half is an equal
X is equal to 6. Yeah, okay, so Kennedy brought it up. I'm going to go down this road. Yes, we're going to go on an adventure. You can just watch. If it makes no sense, we'll still practice. Okay, so again, our problem was 1/2 x is equal to 6. Do we agree with that?
Yes.
What operation is happening to x? It is getting multiplied. Do we agree?
Yes.
In order to undo multiplication, what operation? We do division. So again, just watch how I'm writing it. It's not going to make sense. I need to divide by 1/2. Whatever I do to one side,
Wouldn't that be the
pause. Yes, you're getting there. You're getting there, Luzon. Just one step at a time. Okay? When I divide a number by itself, it cancels out, and I'm left with x. when I do this, 6 divided by 1/2. Mom, what were you about to say?
Like I was gonna say, I was asking if I was a English.
It sort of kind of, yeah, okay? And then when I divide by a fraction, Cameron, you with me? When I divide by a fraction, there was something special we need to do.
I had a put over one for that.
What was that?
Divide by the reciprocal. Yeah, that's what I mean. That's what I mean.
By the reciprocal, good. So which one do I do the reciprocal of?
The second one.
The second one. You keep the first one and then multiply by the reciprocal. Good, okay. So that would be 6 times
2 over 1.
2 over 1, which is just 6 times 2, which is, okay. That's the extended version.
I like that one.
Okay, go for it every single time. Okay? If you just want to multiply by the reciprocal, because that's how we got here, whichever way works for you, as long as it gets you there. Okay? So what is the same and what is different? I notice, what do y'all notice? What's the same?
What do you mean?
Is this on y'all's? Yeah, what's the same? What's the difference?
The fractional as well.
Okay, there's a fraction on one.
And you have to flip it. You have to do a reciprocal.
There's x on both of them. In both of them, it equals 6, right? Both of them have x's and both equal 6. But in one case, I multiplied, in one case, I divided.
So,
well, we are not going to call it multiplicative or anything like that. Yeah, we're just going to say in one case, multiplied, and I'll let y'all write that because I don't think I could write that in that case. One case we multiplied, which was with our fraction, and in one case we divided, which is that top one. What time did we get out? 52. 52. Okay. We've still got some time. All right, so let's just do some more practice. Ooh, we got another fraction. We got another fraction. Okay, but guys, I'm not even gonna model on this because this one's too spicy to model. Okay, I'm gonna rewrite just a little bigger so y'all can see 2/3 x is equal to 4. 2/3 x is equal to 4. Now I'm gonna backtrack real quick. When I solved this fraction, all I did was multiply by the reciprocal. So let's figure out, to solve this one, to get x by itself, all I need to do is by the reciprocal. So that reciprocal would be times 3 over 2 times 3 over 2. Okay, y'all go ahead and try it, solve that out. Okay, it's a little spicier, pause and play with your right side. All right, so on this side, what ends up happening when I multiply on this left side? It cancels each other out, it equals, and so I'm just left with x. Okay, to multiply a whole number by a fraction, I can put it over 1. Okay, up top I get 12 over 2, and that simplifies. 12 divided by 2 is 6. Very good. Okay, again, of course, you can check 2/3 times 6. I want it to equal 4. You can put that over 1, that gives me 12 over 3, which is 4. I know it's crazy because you don't have to check it, I'm just showing that you can. Okay, let's see. Let's just do the math for this one. Let's do x over 2 is equal to 10. Y'all walk me through it. X over 2 is equal to 10. What operation, Rory, do you see happening to x? It's getting divided. Do y'all agree with that, class? When it's a fraction, it means division. To undo division, I need to multiply. Very good. Yeah, very good. So I need to multiply both sides by. I'm just going to multiply. Not 2 over x. I just want to get rid of that 2. So I'm just going to multiply by 2. Multiply by 2. Okay. I want to undo the division, right?
How do you do 2 times?
Okay. So I'm just going to, because, yeah. Yeah. Okay. So that's going to leave me with, what on this side? X. And then 2 times 10 is 20. Okay. All right, so we're just gonna do some partner practice with the people at your table. Be careful, Miss Lytle threw in some spicy.
Thanks.
Okay. You don't have to model. All you have to do is split it and do the operation that undoes it. So on this first one, what operation do you see happening?
Multiplication.
Undo it with division. On the next one over here, I see division. I undo it with. Okay, just do it each time. I'll give y'all 2-3 minutes and then we'll check it. Ready, set, go. All right, so I see what's happening to X is getting, sorry, undo with division, divide by, divide the same thing. Okay, this cancels out. I'm left with X. Signs are different. Negative wins it 5. Negative 5. Okay, next one. What is happening today? It is getting divided. We undo division with multiplication. So I'm multiplying both sides by 8. This cancels out. I'm left with J is equal to 48. Okay. That next one. Ooh, I see one of those fractions. How did we get rid of the fraction before? Very good. Okay. Some of y'all, I know we're not at the shout out point, but hopefully you're hearing it enough times that it'll sink in. We need to multiply by the reciprocal. The reciprocal of the one that's attached to the variable. So that reciprocal is 6 over 5. 6 over 5. So I can cross simplify, multiply. That cancels out on 1 second. I'm talking and recording. It's hard to do. Okay. So we're at K is equal to. You can do that across. You get 30, which simplifies down to 1 over 5. I think what Mom was saying also works. When I do 1/6 times 6 over 5, if you remember cross simplification, both of those 6's cross out to just become 1, and then you get 1 and 5. That is if you still remember how to do that, you can absolutely do that. Okay? Other side. What is happening to R? It is getting
divided. So
it is getting divided, so we undo with multiplication times both sides by -7. That cancels out. R is equal to
35 because both of them are the same.
signs are the same, positives the game. Okay, if you're staying quiet, hopefully you're getting this and listening and catching on. Okay, this one was a tricky one. We got a couple of y'all. What's happening to Q?
It multiplies and divides.
Very good. I still need to divide by -35, -35, but where we got to is this part right here.
I don't get how
Okay, if I divide 5 divided by -35, I know my answer is going to be positive or negative? Negative, but -1. Not 7. That would be if the order was switched, but we can't.
Wait, not, did I say just
-7.
It's not -7. It's -5 over 35. That's going to be less than 1. That is going to be the same thing as -1/7. Because I just simplified that fraction.
That's gonna get me on the quiz.
Spiky. Okay, last one. Pause, last one. Okay, what kind of fraction is this? This is a mixed number. It's mixed because it has a whole number and a fraction. That's a mixed number. Let's get rid of that because I can't do the reciprocal of a mixed number. So how do I turn 1 2/3 into a mixed number? Texas. Very good. Texas, T, and the X. Ooh, y'all remember that?
Yeah.
Okay. I do 3 times 1 is 3 plus 2 is 5/3. J is equal to 15. Now it looks like what we're used to. And to get J by itself, I
Have to multiply them.
by the reciprocal. So that's going to be
1. Or this
multiply both sides by
35.
3/5. Okay, and solve that out. Your homework. So guys, technically this is a no homework night, but please Get some practice for that quiz that's on Wednesday, that back page. Okay, it's not a sign, but please practice.